Find the first four partial sums and the nth partial sum of the sequence given by c sub n equals log of n over n plus 1. First, let's look at the first few terms of this sequence, and then we can look at the first few partial sums. The first term, c sub 1, we get by looking at log of 1 over 1 plus 1, or log of 1/2. Now, we can't evaluate that very nicely. The best we could do is a decimal approximation if we wanted an idea of what this is equal to. But we don't want to deal with decimal approximations, so we're going to leave it just like it is. So we have log of 1/2 for the first term. For the second one, c sub 2, we're going to have log of 2 over 2 plus 3, or log of 2/3. For the third term, c sub 3, we'll have log of 3 over 3 plus 1, or log of 3/4. And you can see the pattern here. After that, we're going to have log of 4/5, log of 5/6, etc. So now we want to look at the partial sums. So for the first partial sum, we know this is equal to just the first term, log of 1/2. For the second partial sum, we know we need to add the first two terms, so log of 1/2 plus log of 2/3. But we have a law of logarithms that says if we have the sum of two logarithms, we can combine them into one logarithm by putting the product of the two arguments of the logarithm inside. So we can write this as log of 1/2 times 2/3. And we know that when we multiply those, the 2's cancel, and so we end up with log of 1/3. So the second partial sum is log of 1/3. Let's look at the third partial sum. Here, we're going to have to add the first three terms of the sequence. So log of 1/2 plus log of 2/3 plus log of 3/4. We can use the same law of logarithms to combine these all into one logarithm and write it as logarithm of 1/2 times 2/3 times 3/4. And again, we're going to have some cancellation here. The 2's and the 3's cancel, leaving us with log of 1/4. Hopefully you're seeing the pattern here. We've got log of 1/2, log of 1/3, log of 1/4. The next one, s sub 4, we can conclude is going to be log of 1/5. And we should be able to conclude that without actually writing out all the work, because s sub 4 is going to be the sum of these plus log of 4/5, and then when we combine them into one logarithm, we're going to have one extra factor in here, 4/5. The 4's cancel, and we're left with 1 over 5 inside, so we've got log of 1/5. We can see that each of these partial sums is going to be log of 1 over a number, and the denominator is 1 more than the number of the term that we're at. So the first partial sum is 1/2, the second partial sum is 1/3, the third partial sum is 1/4, the fourth partial sum is 1/5, and we can conclude that the nth partial sum is going to be 1 over n plus 1, because the denominator is always 1 more than the particular sum that we're looking at. So in this case, the nth partial sum is log of 1 over n plus 1. This is another situation where we have a lot of cancellation. In this case, we've got things canceling in numerators and denominators. In the previous problem, we had positive and negative terms that were canceling out. These are some very interesting techniques that we might use later on in Calc 2 when we're looking at sequences and series.